Okay. Now, those of you that have already had class, we might have said tides and eclipses notes. Well, this is just going to be the notes on tides. So you're going to have eclipses after this one. We'll post that a little bit later. But anyways, so today's notes are on tides. Tides are caused by the moon's gravitational pull on the Earth. So since the moon is the closest object to us, the moon is what pulls the water on the surface of the Earth towards it. Okay, and it kind of creates a tidal bulge on one side of the Earth, and so that's going to cause it to be lower on the opposite corners of the Earth. We'll talk about that in a second. Now, a small part is because of the sun also. Okay, because when the sun and the moon are working together, the tides are going to be bigger. They're going to be more drastic. When the moon and the sun are pulling opposite of each other, the tides aren't going to be quite as dramatic. Okay? Now, the tides occur approximately every 12 hours and 25 minutes between high tides or between low tides. It's every 12 hours and 25 minutes, give or take a little bit. Now, the reason that it's 12 hours and 25 minutes is because you get, and I'll show you this on the next slide here, what happens is you get a high tide on both sides of the Earth. Okay? You get a high tide on the side towards the moon, and you get a high tide on the opposite side of the moon also. Okay. So, the types of tides. Two types of tides. You have a spring tide is the first one we're going to talk about. It's when you have very, very high and very, very low tides, meaning your tidal height, okay, the height of the water. So let's say this is where the water is normally. Well, the high tide is way up here, and then the low tide is down quite a bit. Okay, big change from the high tide to the low tide. I mean, there's places where they have a difference of 12 to 13 feet in the change from high tide to low tide during a spring tide. Okay, but that's what the tide is the change in the height of the water. Now, the Earth, the sun, this is caused by the moon and the sun pulling on the Earth. So it's pulling on the water. It's moving the water on the surface of the Earth, okay, and causing it to be deeper at high tide and lower at low tide. Now, the Earth, the sun, and the moon are at 180 degrees or a straight line. Now, one easy way to remember this is spring tide, straight line. Okay, spring tide is a straight line. Okay, 180 degrees. Now, what we mean by this, if the sun is here and the Earth is here, ignore this one right now. Okay, you'll have a high tide when the moon and the sun are pulling together. The moon is what causes the tides, but the sun helps out a little bit. Okay, in this picture. Now, you'll get a high tide on this side of the Earth and on the opposite side of the Earth. So even though the moon's on this side, you're going to get a high tide on both sides of the Earth. Now, on the opposite, 90 degrees to that, you're going to get a low tide up here and a low tide down here. Now, since the Earth is rotating, it takes 12 hours and 25 minutes between the high tides. Now, yeah, you'd think it'd be exactly 12, but it's all because the Earth is also revolving around the sun a little bit in 12 hours. So that's what makes up that 25-minute extra, okay? Because the Earth is revolved around the sun just a teeny tiny bit, and so the Earth has to rotate that little bit extra, that 25 minutes extra to get a high tide over here, okay? So, if you ever were asked a question, what's the time between high tide and low tide? Well, if it's 12 hours and 25 minutes between high tides, well, that would be about 6 hours and 12 or 13 minutes, okay, from high tide to low tide, okay, just so that you understand that. But the big thing that you need to get is a spring tide. The Earth, the sun, and the moon are in a straight line. Could also happen when it's at a full moon. So it's only going to be a new moon or a full moon with a spring tide, okay, because the sun, the Earth, and the moon are in a straight line, 180 degrees with each other, okay? Now, with the Neap Tide, Neap tides are not as drastic because the sun and the moon are working against each other. They're kind of in a tug of war. Okay, the moon is what greatly affects our tides, but the sun is still pulling on the earth. Okay, even though we're much farther away from the sun, there's still a pull there. Okay, but it's not enough to cause our tides. The moon is so much closer, that's what causes our tides. So, the earth, the sun, and the moon are at 90 degrees to each other. So remember this, a neap tide, 90 degrees. Okay, so a neap tide is 90 degrees. All right, the sun, the earth, and the moon are at 90 degrees to each other. Or down here in a third quarter. Okay, now, again, high tide when the moon is here at the first quarter, and also high tide when you're down here on the earth. Okay, so as the earth rotates around, you're going to get a high tide when you're on this side, you're going to get a high tide when you're on that side. Low tide is when you're either here or on the opposite side there. Now, the reason that these aren't as dramatic is because the sun is still pulling on the water a little bit, but since the moon is so much closer, it's going to pull the most. But the lows aren't quite as low because the sun is still pulling a little bit, and the highs don't get quite as high because the sun is pulling a little bit. Okay, so you'll get a neap tide at a first quarter and a third quarter moon. Now we're going to be doing a lab that is going to be related to the tides, and so we'll be talking about this more. But just for example, I mean, there was a time when I came into Bar Harbor, Maine. And in Bar Harbor, Maine, I must have come in on a spring tide. It was the first time I really, truly realized what tides were and had a chance to experience it. But only when we came in to Bar Harbor, came down this one road that went right by the ocean. Okay, a whole bunch of boats out there floating around, and the water was right up close to the road. Okay, we got checked into our hotel, got our stuff unpacked and everything, and decided to go back out, and we went right down that same road with where we were heading, and just to check the town out and everything. And it would have been a few hours later. And so as we were driving down that road, all of a sudden I looked out at the harbor, and there were only a few boats there. But the boats that were there were sitting sideways. Okay, they were tipped right over on their side because they were on dry ground. They were sitting on sand. And some boats were still floating, but they were way, way out in the harbor. It must have been a spring tide when we were there, because it was a full moon time when we were there, and so it definitely was a spring tide. And the tide changed very, very dramatically. And people that live around the ocean, they know when the tides are. They have to plan that out. It's in their weather forecast in the morning when they watch the weather in the morning. So they know what time. If you're going to go out on a boat and you tied your boat in close to shore, and all of a sudden it's a low tide, you're not going anywhere because your boat's sitting on dry land. Okay, you got to wait that extra time for the earth to rotate so that you're back at high tide, so your boat's finally floating again and you can go back out. Either that, or you have to tie your boat out farther out into the ocean and have a little rowboat or something that you use to, or swim to it. But that's how it works. So this is a little bit on tides. So spring tides, Earth, the Sun, and the Moon are in a straight line. Big dramatic changes in tidal height. And then during the neap tide, the Earth, the Sun, and the Moon are at 90 degrees to each other. First quarter, third quarter, not as dramatic. Okay? All right.